Okay, how's everybody doing today?
Uh,
Doing great, doing well. Okay. So I checked with the administration. The seniors are, of course, are taking your finals on Monday and Tuesday, but I did get confirmation for this. So on Monday, seniors will be taking your finals for your odd numbered classes. And I wasn't sure. This is what they did last year, but I actually did get confirmation. And then on Tuesday of next week, you'll take your even numbered finals. So you guys will be taking the final if you're senior on Monday, and then everybody else will take it next Thursday. I'm thinking what's going to happen is I've already put aside this Thursday, the entire class period. I'm going to go ahead and give everybody the review, and that's the day y'all can work together. And here's what's nice about this. The review is only 10 questions. The final is the exact same 10 questions. Use what stuff? I'm fine with that because you guys are going to be answering it. Okay. Yes. No, they're still regular full days. Yeah, so it's they did it because, well, for a couple of reasons. One, they don't want you to have back to back to back to back to back finals on one whole day, but also it has to do with attendance, because if you only had like periods 1 through 4, then people might disappear in the afternoon classes. Yeah, so Mr. Q. What?
Catch.
Nice. There we go. Okay, that's cool. Okay, thank you very much. Oh, if you'll send it in the trade. Okay, so that's about the final. So Thursday we are going to just take the period. I'm going to let you guys work together. It's cumulative from concepts we've had from throughout this semester. What we're going to be doing today and tomorrow, we're going to go ahead and do a small little lesson. Should be an easy way to end the school year pretty much because, next Monday you got the finals. Yes, ma'am. I'll give it to you on Thursday. So this Thursday. Oh, okay. Then I guess I'll go ahead and give it to you tomorrow. Okay. Go ahead and remind me. I'll give you guys the review tomorrow, so you can go ahead and start taking a look at that, Brandon. Honestly, that's kind of what I'm thinking. We're at the end. Well, I may fit a little bit more math in there, but we'll go ahead and take some time to. We'll take some time to definitely relax.
Oh my God.
That's perfect. I mean, it's probably the thing to do anyway that last week because half the class is going to be gone.
Mr. West. Like tomorrow or something, I gotta show you. I found this really cool math equation that calculates like game of the year, like
Oh, really?
based on mom and like the X power. Like it's really cool. I gotta show
Okay.
you. I love
Lexi.
it.
There was a toad in my front yard, and then he went in her driveway. My mom actually ran over it.
My mom hit
Oh,
it
God.
the other day.
That is sad.
I took some pictures before he died. I just finished one of those moments before death.
Wow. Maybe the toad was tired.
Hey.
Tired. Tired.
I thought it was tired.
Yeah. Glass is half full. We got to get something out of it. Okay. Okay. Well, that's the plan. So, we really don't have a whole lot left. In fact, tomorrow, your focus activities are going to be due, and this is one of the last grades of the 6 weeks. Speaking of last grades, your test is on Friday. That's multiple choice. Let's use your notes. Hopefully should not be any issue. In fact, next week, anybody who is absent will probably just take care of the makeup work at that point. But this right here, this is the last focus activity of the school year, the final one. I'm sorry, Nathan? Yes, you have till tomorrow. Now, if you want to go ahead and turn them in today, that's fine. But tomorrow, I'm going to be looking for numbers 3, 4, 5, 6. Okay. And Marcus, you had a question? Oh, never mind. Okay. All right. Well, this focus activity is based on what we just currently finished. It says use Pascal's triangle to expand 2x minus 3y to the 4th power. Okay. So one thing I'm going to need is the binomial theorem. I need Pascal's triangle. So let me go ahead and pull this up very quickly. Now, I want to raise this to the fourth power, so I'm going to be using the fourth row. Remember, in Pascal's triangle, you always start counting with what? 0, and then 1, 2, 3, 4, and so on. So I want these coefficients, 1, 4, 6, 4, 1. Okay, so I'm going to come on back over here. So 1, 4, 6, 4, 1. Okay. And then now for each of these coefficients, I want to go ahead and put the terms that I'm using. Okay, what are A and B? So I'm going to put 2x, and then what am I going to put right next to it? Negative 3y. There we go. So 2x, negative 3y, 2x, negative 3y, 2x, negative 3y. Move this 1 over just a little bit. Okay. And then 2x. Let's see if I can fit it in. Perfect. Okay. So now each of the coefficients that I got from Pascal's triangle, I put the terms next to it, both A and B. What do I do now with powers?
Start at the top, like so. The A power.
Uh-huh.
You'll start at the top and count down, and then the B power you'll count.
Okay, so the first term's powers will count down. So I'm going to start 2x with what? 4. So there's 4, 3, 2, 1, 0. And I want to go ahead and count up for the B term. But I start at 0, 1, 2, 3, 4. And there we go. Now, because I'm subtracting, what do I expect to see when I expand my answer? It should alternate. It should be positive, negative, all the way across. Okay, so let's see here. This gives me a 1, 2x to the fourth. What's 2 to the fourth? Oh, you're right, 16. So that's 16x to the fourth, and then negative 3y to the 0, well, that's just 1. So this would just be 16x to the fourth. Okay. And then we just need to go along each one of these and go ahead and simplify everything we have. Yes, so this next one should turn out to be negative. So let's see, I got a 4. What do I get if I cube 2x? 8x cubed, there we go, times 8x cubed. And then negative 3y to the first, well, that's just negative 3y. Okay. So we definitely know it's got to be x cubed y. Okay, so let's see, 4 times 3? 12 times 8. 90, oh, a little low. Okay, 96. Okay, so then we know it's negative because the negative times the 2 positives. Is everybody okay so far? Okay. So see, now we have a 6. If I were to square 2x, that would be 4x squared times, what do I get if I square negative 3y? Positive 9, and then y squared. So I know this term is the x squared, y squared term. They're all 3 positive, so that's a plus. Okay, so I need 6 times 4 times 9.
9 times 4 is 36. 36 times 6 would be
206? I don't know off the top of my head.
72 plus 72.
24 times 9, or 36 times 6, yeah.
So, because 36 plus 36 is 72, 72 plus
216.
There we go. Perfect. Okay. Next up, then this one has the 4. 2x to the first stays 2x. What's a negative 3y if I were to cube it? So negative 3 times negative 3 times negative 3. Negative 27. Y cubed. There we go. So 27 times 2 would be 54. And then 54 times 4, that would be another what? Another 216. But this time it's negative, so minus 216 y cubed. And our last one here, well, we have the 1. 2x to the 0, that's a 1. Oh, did I mess up? Oh, I forgot the x. You're absolutely right. My bad. You know, the end of the year, I got to make sure you guys are paying attention. Those little, there you go. XY cubed. There you go. All right. And let's see. So we got 1 times 1. Now, what is negative 3y to the 4th?
Negative 20. Oh, no. And negative 3y.
Oh, well, it would definitely be positive.
Oh.
81. 3 times 3 times 3 times 3. There we go. There we go. All right. So there we go. That would be the expansion of 2x minus 3y to the 4th. Okay. So you have some questions. In fact, I think that's more difficult than any question you got on your homework. Now, number 2 is also like some problems you have on your. Oh, don't erase it yet? Okay. So it looks like for number 2, I want to find the coefficient of the x to the 6th y cubed term for the following binomial, 2x plus 3y to the 9th. Okay. All right. Can I erase it? Is everybody good? Okay. All right. So let's see here. Okay, so first off, what we're going to need is the combination. Remember, this is something that we thought of yesterday, the combination of n and r. So this was n factorial over n minus r factorial times r factorial. So what does factorial mean? So like if I were to give you 7 factorial. Yeah, so 7 times 6 times 5 times 4 times 3 times 2 times 1. What you do is you multiply by the values below the number you're given, the whole number values, all the way to 1. Okay, well, let's see here. Does anybody remember looking, I want the x to the 6th y cubed. What is r?
R would be the second.
There you go. That second power, that's always r. So I know r is 3. What's n? 9. Okay, n is always the original power you're going to place on your binomial. Okay, so let's go ahead and figure out what that's going to be. So that would be 9 factorial over, we have 9 minus 3, so 6 factorial, and then 3 factorial. Everybody okay with how I plugged in? Okay. Now remember, we could either do this by hand or we could do this in the calculator. What would you prefer? By hand? Okay. So now I'm going to go ahead and write out the 9 factorial. But let's stop at the 6. There we go. So 9 times 8 times 7 times 6. Okay. It's over 6 factorial, 3 factorial. So those are going to cancel. So really this is 9 times 8 times 7 divided by 3 times 2. This would be 6. So we could go ahead and simplify this even further because 9/6 will be 3 halves, right? But then you'll notice the 8 can also simplify with the 2. So I can go ahead and say that's 4, that's 1. Okay. So 3 times 4? 12 times 7. Okay. 82? 84. Okay. So does that mean the coefficient of that term is 84? We're not done yet, so what do we do? There you go. Now we're going to put the terms from my binomial. So we have a 2x, we have a 3y. What powers are going to go on them? 6 and 3. There we go. So I've got the 84. Now 2 to the 6th, what would that be? It's in the 60s. 64. So that's 64 x to the 6th times 3 cubed, 27. Y cubed. So 84 times 64 times 27, which is going to give me a rather large number. So 84 times 64 times 27. 145,152. 145,152 x to the 6th y cubed.
Oh, real quick. So like what's that? 987
Uh-huh. Bless you. Oh, well, what I did was, let me go ahead and go back to what I had here. So originally we had 987, right? So the 9 over 6, that simplified to 3 over 2. But then the 2 can simplify with the 8. So then I went ahead and marked that out, and that became the 4. And see, all I had left was 3 times 4 times 7. Brandon, is that good? That's not good?
So, okay, so why do you have 6 over there instead of 3? You crossed out the 6.
Oh, because we crossed out the 6's, but remember 3 factorial is 3 times 2 times 1, which is 6.
So then, so 6 times, so 9 divided by 6 would be 3 over 2.
Mhm.
Okay.
And actually, I mean, if it helps, we could do this. We could say 9 times 8 times 7. Now, instead of 6, I could just break it apart into 3 times 2. And then that would be 1, that would be the 3, that would be 1, that would be the 4. Does that kind of help out?
Yeah.
Cool. All right. Questions? Okay. All right. We'll probably go ahead and stop, I'd say, at least 5 or 10 minutes early. That way, if you want to go ahead and turn in your focus activities, I recommend just getting done with it. Go ahead and turn them in. Not right now. We'll wait to the end. Can we watch what? Graduation fails this early? If you want to. Won't that kind of maybe psych some people out thinking about that's not what I want to do, and then you actually fall on stage?
That's the point. You want them to fall.
I'll tell you,
Want them to go for the world.
this is my 16th year at Lubbock High, and I've been to the past 15 graduations, and I have not yet seen anybody trip or fall. Now, I have seen, there have been some years, of course, every year people have the air horns. You know, of course,
Oh, yeah.
they say a name and then it's, and then you can't hear the next name being called out. You know, it's great.
Yeah,
But
that was
there have been years, beach balls were thrown from the crowd. Those Super Balls are a crowd favorite. You know those little bouncy balls?
They do that?
Yeah, they haven't in a couple of years, but they have in the past. The only time it got really dangerous, those larger baseball size bouncy balls, people were launching those from the stands, and that will hurt, Now, I'm not giving anybody any ideas. We don't want that to happen. Okay, I'm just saying. I haven't seen any. Okay.
So we can turn these in like now.
We'll turn them in right at the end.
All right.
Okay, so let me go ahead and introduce you to polar coordinates. I had thought about, moving on to conics, but then I really got to thinking there's no way we're going to finish that. I can at least give you an introduction to polar coordinates. Okay, so here we go. You've graphed equations in a rectangular coordinate system. When air traffic controllers record the locations of airplanes using distances and angles, they're using a polar coordinate system or polar plane. Now, this second paragraph here is talking about the rectangular coordinate system. Okay, that we already know about. Okay, you move horizontally and vertically to locate a point. We already know about that. So let me go ahead and show you the polar coordinate system. In the polar coordinate system, the origin is a fixed point called the pole. So we still have the intersection of my two axes. It's kind of like we're on the unit circle, but we don't call it the origin anymore. We call it the pole. Okay. Now, you remember when we did have our coordinate plane, or I should say the unit circle, standard position is where we started to rotate. Remember the positive x-axis? Okay. Well, here we no longer refer to it as standard position. When you're dealing with a polar coordinate system, you call it the polar axis. Okay. And here's what the points are going to look like. The first value will be your radius, the length of your terminal side, and then theta is going to be the degree or radiant measure that you're provided. And it's still the same. Remember, if you have a positive value, you'll rotate counterclockwise. If it's negative, you'll rotate clockwise. Now, let's go ahead and do a quick comparison. Here's a regular XY coordinate point that we were used to. Here's the radius and theta for a polar coordinate. Now, how do I graph an XY point? Which one do I start with? You always start with X, right?
Now you start with the theta.
You start with the theta. So X tells you to move horizontally left or right, and then you look at the Y value, which tells you to move vertically. But it's reversed when you're looking at a polar coordinate. You want to start at the degree measure first. You want to figure out where that terminal side is going to stop. And then once it does, then you go ahead and figure out what the length of the radius is going to be. Okay. So let's try a few of these. Before we get to a grid, here's some examples. So this paragraph is really saying everything I've already talked about, except for the last two sentences. It says if the radius is positive, then your point P lies on the terminal side of theta. It'll go ahead and be exactly where you think it is. But if the radius is negative, point P is going to lie on the ray opposite the terminal side of theta. Okay, so I'll explain what that means in just a second. Let's say that this represents your positive x-axis. Okay, so right here you've got the pole, which would be the origin of your grid. Then we have, this line right here. This is what we call the polar axis. Okay, so I want to go ahead and use this to graph the point 45 degrees. Okay, so let's think about it. 45 degrees, what quadrant would that be in? First quadrant, right? Because quadrant 1 goes from 0 to 90. Okay, so what I'm going to do here from the polar axis, I'm going to rotate 45 degrees. Okay. So let's say I have my terminal side right there. I'm going to draw the terminal side where it should stop. Well, then along that terminal side, I want to find the length of 2. So 1, 2, let's say 2 is right there. That would be point A. There you go. That's how you plot a point if it's a polar coordinate. You find the angular degree measure first, and then you go out from the pole, whatever your radius is. Okay. Let's try another one. Okay. Point B. We have a radius of negative 1.5 and 2 pi over 3. Okay, so who can help me out? What quadrant would 2 pi over 3 be in? That would be in the second quadrant. Okay, that's correct. So if I started here and I rotated, 2 pi over 3 is going to put me in the second quadrant. Okay. Now, this is when I turn to the radius and I go ahead and from the pole count out that length, right? So I would go ahead and say here's 1, here's 2. So 1.5 is going to be right there. Now, this would be correct if the point was 1.5, 2 pi over 3. Okay, but the radius isn't 1.5, it's what? It's negative 1.5. This is what that last sentence was saying here. If the radius is negative, you're going to take this line, the terminal side, you're going to draw it in the exact opposite direction, and then you're going to go ahead and find the length of that radius. But you only do that if the radius is negative. You find that distance in the exact opposite direction. So even though 2 pi over 3 is in quadrant 2, this point would actually end up in the fourth quadrant. Okay. And we're going to practice this. That's what today is. We're just kind of an introduction to these things. Okay. Let's try C. 3, negative 30 degrees. All right, so start with negative 30. So how do I rotate? Clockwise. So it's going to rotate me into quadrant 4, right? So let's say this right here. So here's the negative 30 degrees. Now, because R is positive, I'm not going to go in the opposite direction. I only do so if the radius is negative. So with a radius of 3, 1, 2, 3, okay, there would be point C. So that point would actually be in quadrant 4. Now, in fact, I'm going to go ahead and show you now a polar coordinate grid. And actually, it's going to look very similar. Have you ever seen a tree that's been cut? When you look at it, what do you see a bunch of? A bunch of rings, right? You can count those to tell how old the tree is. Well, really, that's what you're looking at when you have a polar grid. Okay? It's going to look just like this. See, you got your measures all the way around here, both in degrees and radians. Okay? The origin is now called the pole, and this is the polar axis. From here, we're going to rotate clockwise and counterclockwise. Okay. And we have a couple of points that we're going to go ahead and graph. So we want to practice locating point P, which is 3, 4 pi over 3. Okay. So let's start there. What quadrant would 4 pi over 3 be in? Okay, it's the third quadrant. So say I'm going to start here, and I'm going to rotate all the way around until I find where my measure is. Okay, so you'll notice this innermost circle right here, that would be a radius of 1. Then 2, then 3, then 4. So you just count out from the pole. So I found 4 pi over 3. So along that line, how far out do I want to go? Yeah, I want to go out 3. So the smallest circle, that's 1, 2, 3. That would be point P. You rotate clockwise or counterclockwise depending on your angle measure, and then from the pole you go out the length of your radius. That's how you plot a point in a polar coordinate system. Okay. All right, let's try Q. Well, where's 150 degrees? It's in the second quadrant. Okay, so I'm going to rotate. So here's 150 degrees, radius of 3.5. So starting from the pole, 1, 2, 3, and then I'm going to go halfway for 0.5. Okay, what do you think? Am I forgetting anything? What? It's a negative radius. Now, if this had just been 3.5, that's point Q, I'd be done. But what do we do if the radius is negative? There you go. I'm going to follow this line all the way through to the other side. So this is the actual line that I need to be on. So from here, I'm going to count 1, 2, 3 and a half. So that would be point Q. Okay. Remember, if the radius is negative, you go in the opposite direction. Okay. All righty. Thanks, sir. What's the 14th? Okay. I wish it was. Okay, there you go. Is anybody having a hard time plotting a polar coordinate point so far? Okay. Well, let's try C. Now, what's different about this one? Okay, so it's negative, so I have to rotate what direction? Counterclockwise, or clockwise, I'm sorry. Because we had to go this way because it's negative. So some people in the other classes have been having difficulty figuring out where to stop. So think about it this way. If it was a 7 pi over 6, if it were positive, then I'd start here and I'd rotate all the way around, right? Okay. Well, you'll notice I had to go halfway and then I had to go 2 extra increments in order to get there. Well, why don't we go that exact same distance, just rotating clockwise. So if I start here, I'm going to definitely go halfway, and then I'm going to go 2 more. So I want to be stopping on that line right there. Okay. And what's the length of the radius? 1.5. So I'm going to go ahead and count that out. From the pole, 1, and then halfway between the first and the second circle. So right there, that would be R. Anybody confused? Anybody not sure how I'm doing this? Okay. Well, let's go ahead and plot these 2 points right here. Try these on your own. Plot points A and B. I got 4, 210 degrees, and then -4, 210 degrees. Okay. I'll give you a few seconds to see where those might end up. 4, 210 degrees, and -4, 210 degrees. Excuse me. Tired. No, you got to get another copy. Yeah. No, it builds character. All right. So who wants to help me with point A? 4, 210. Does anybody want to come on up and show me where point A would be? Okay. Lexi? Okay. So she's going to mark point A on our grid. Okay, so we're going to find 210. Okay, is she right? Is that where A should be? That is absolutely correct. Very good. Okay. Now, what's the difference between A and B? Okay, the radius is negative. What do we do when the radius is negative? There you go. So we originally went to 110, so I'm going to go back across. That's where I need to go ahead and do it. Remember, if the radius is negative, you find that length in the exact opposite direction. Okay, so I'm going to go ahead and find the 4. 1, 2, 3, 4. That is where point B should be located. How many people got those right? Okay. All right, so we're going to practice a little more, okay? But I think that's where we're going to go ahead and stop today. That's just an introduction to polar coordinates. Okay. All right. Okay, good job. Okay, so if you want to go ahead and turn in your focus activities, numbers 3, 4, 5, and 6. Otherwise, tomorrow is when I will actually be looking for those.